Good day, students. This video lesson is the continuation of our discussion of the topics in Module 10. Last meeting, we discussed the considerations and steps to observe in planning your data collection. Now that you know how to collect the data for your research, you may ask, how will I examine and analyze this data properly? Numbers or figures simply presented will not be easily comprehended, and their significance will not be determined without a correct analysis. Analysis is the process of breaking a whole into parts. The researcher must be critical in looking at details to prove or disprove a certain claim or theory. In analyzing the data, the following must be considered. The highest numerical values such as scores, weighted means, percentages, variability, etc. Next, the lowest numerical values such as scores, weighted means, percentages, variability, and others. The most common numerical values like mode or values that appear repeatedly, and the final numerical value like the average weighted mean, total, chi-square value, correlation index, etc. Some of the words that I've mentioned were quite technical, but I believe you have encountered these words in your statistics and probability. In this lesson, you will re-encounter some of those terms, since data analysis for quantitative research is impossible without the use of statistics. Okay, so now what is statistics? Statistics, as you already know, is the body of knowledge and techniques used in collecting, organizing, presenting, analyzing, and interpreting data. It is a prerequisite in any research that the researcher has sufficient knowledge of various statistical techniques. There are two branches of statistics. First, we have the descriptive statistics, and the other one is what we call the inferential statistics. Descriptive statistics involves in tabulating, depicting, and describing the data collected. The data are summarized to reveal overall data patterns and make them manageable. While inferential statistics involves making generalization about the population through a sample drawn from it. It also includes hypothesis testing and sampling. Similarly, it is connected with a higher degree of critical judgment and advanced mathematical modes, such as parametric, wherein we use parametric type of tools in an interval and ratio scale, and non-parametric for nominal and ordinal statistical tools. There are several types of descriptive statistics as well as several types of inferential statistics, which we will be discussing later. But to be able to decide whether to use descriptive or inferential statistics, you have to know the levels of measurement of variables first. So what are levels of measurement? The level of measurement refers to the relationship among the variables that are assigned to the attributes for a variable. What does that mean? Begin with the idea of a variable in this example. Party affiliation. That variable has a number of attributes. Okay, party affiliation. So we are using the United States election this time as an example. Let's assume that in this particular election context, the only relevant attributes are Republican, Democrat, and Independent. For purposes of analyzing the results of this variable, we arbitrarily assign the values of 1 for Republican, 2 for Independent, and 3 for Democrat. The level of measurement describes the relationship among these three values. In this case, we simply are using the numbers as shorter placeholders for the for the lengthier text terms, or shorter name for the attribute. Okay, again, the shorter name for Republican in this example is 1. The shorter name for Independent is 2. The shorter name for Democrat is 3. We don't assume that since we wrote 1 under Republican, that Republican is number 1 or they are the winner. No, it doesn't work that way. Okay, we are just again using these values or these numbers as shorter name or representation of the lengthier texts. So in this particular example, we would describe the level of measurement as nominal. Why is level of measurement important? First, knowing the level of measurement helps you decide how to interpret the data from that variable. When you know that the measure is nominal, just like our example earlier, then you know that the numerical values are just short codes for the longer names. Second, knowing the level of measurement helps you decide that statistical analysis or what statistical analysis is appropriate on the values that were assigned. So if a measure is nominal, then you know that you would never average the data values or do a t-test on the data. There are typically 4 levels of measurement that are defined. First is nominal, second is ordinal, third interval, and the last one is ratio. Nominal data are attributes that only name variables. These data are considered as the simplest level. Some examples are numbers on the uniform of basketball teams, naming the data for statistical purposes like male for 1 or 1 for male and number 2 for female, and the students' favorite colors, yellow, green, red, and so on. Next is ordinal data. These are attributes of variables that can be placed as 1 is higher than 2. They can be used for ranking purposes, and they are mostly used in Likert or Likert scaling. So example, 1 means very good, 2 means good, 3 means fair, and 4 means poor. The third level of measurement of variables is what we call interval data. These are attributes of variables in where the distance from one number to the other has meaning. These are basically the types of values in which there is no true zero, and a researcher can only use subtraction and addition. So examples are IQ scores, means, weighted means, the difference in the temperatures between 10 a.m. and 12 p.m. and others. And the last level of measurement of variables is what we call ratio data. These are attributes of variables that has a natural zero. Okay, take note. If interval data has no true zero, ratio data on the other hand has a natural zero, or it has true zero. These types of variables can be multiplied and can be divided. Alright, examples are weight, height, age, number of customers who complained for the month, absence of money in the pocket. So they are the types of ratio data. Since example in age, so 8 is twice as older as a 4-year-old. Okay, so those types of data are called ratio data. Now that we learned the levels of measurements of variables, let's proceed to the common statistical tools. Statistical tools are divided into two major categories. The first one is descriptive statistical tools, and the other is inferential statistical tools. Under descriptive statistical tools, we have frequency distribution, proportion, percentage, measure of central tendencies such as mean, median, mode, variability, range, average deviation, variance, and standard deviation. For frequency distribution, it is the records of the number of individuals or cases located in each category on the scale of measurement. Frequency tells you how often something happened. The frequency of an observation tells you the number of times the observation occurs in the data. For example, you surveyed milk tea shop preference in General Santos City. Your tally shows that out of your 400 sample size, 150 respondents chose chai 100 like Gongcha, and 80 like 50, and the remaining 70 respondents chose other milk tea shops. Okay. For proportion, it is the total frequency divided by the number of cases in each category. It can be derived from the frequency distribution. Proportion is also known as relative frequency. As for percentage, it is the proportion expressed in percentage. So we simply transform proportion to percentage. Now let me show you an example of the frequency distribution table. Okay, so we go back to our examples earlier, the preferred milk tea shop in General Santos City. So this is our indicators. So here on the first column we wrote the names of the shops. On the second column we wrote the frequency. The third column is for the proportion, and the last column for the percentage. Now in this example, chai 1 was chosen 150 times. So that means out of the sample size of 400, 150 of the respondents selected chai 1. Okay, so that is our frequency. Now if we want to get the proportion of the frequency, we simply divide 150 to divide it by the sample size which is 400, then our result will be 0.375. So this is what we call proportion or relative frequency. Now we want to get the percentage. We simply transform the proportion. In this example, our proportion is 0.375. We transform it to percentage by dividing it to 100. Then we get 37.5%. So this means 37.5% of the entire population or the entire sample chose chai 1 as their preferred milk tea shop. We proceed now to the measures of central tendency. Measures of central tendency indicates where the center of the distribution tends to be located. It refers to the typical or average score in a distribution. So the first one is mode. It refers to the most frequently occurring score in a distribution. Now let's take a look at an example. So in this example, we can see in the first row that number 5 occurred 3 times. So this is the value that occurred the highest among the values that we see in the first row. So that the mode in this first row is number 5. On the second row, we can see that there are 2 values that appeared repeatedly equally. So this is what we call bimodal. Okay, so 5 and 6. So there's 2 values. We call it bimodal. And if there are more than 2 values that appeared repeatedly and equally, we call them multimodal. Now, we proceed to median, the other measure of central tendency. Median, it is the midmost or middlemost value in a distribution, below or above which is exactly 50% of cases that are found. Okay, now let's take a look at an example. So in this example, there are 11 scores. Okay, 11 scores, right? And then, so let us pretend that these values that we see are scores, examination scores. So out of 100, these are the scores that the 11 students got. Okay, so the middle number of 11 is 6. Okay, 64 then is our median. Okay, you have to remember, guys, that we have to arrange the order of the scores for us to be able to get the correct median. In this case, we arranged the scores from the highest value, which is 95, to the lowest value, which is 30. The third measure of central tendency is mean. It is the exact mathematical center of the distribution. It is equal to the sum of all scored, or the sum of all scores, divided by the number of cases. Mean is also known as average. Now let's see the formula. So this is our formula of mean. Mean is equals to sum of all data values divided by number of data values. So this is our symbol, the formula symbol. I prepared a table so that we can see all 3 measures of central tendencies. So the table here represents the test scores, the students' test scores. So the first column, these are the names of the students who took the test, and there are 11 of them. Okay, so 11 students. That's in the first column. And the second column, column B, shows the marks of each student. Okay, now to get the mean, which is average, we have to add up all the scores and divide it by the number of test takers. So there are 11 test takers. So our average in this example is 61.90 or 90909. That is our average or mean. And our median in this particular example is 64. If we notice in this table, 64 is the last number, the last score. Now we learned that median is supposed to be the middle value. So in this example, the scores are quite scattered. So what I did is I organized it to get the correct median. So I organized it from the highest to the lowest score. And here we can clearly see our median, which is 64. This is the middlemost value. Okay, now to see the mode, we have to check which number repeatedly appeared. So here it says that the mode is number 55. So let's see how many times 55 appeared in this example. So Laura got 55 and Gracie got 55. So there are only two 55s in this example, but that's the only score that appeared repeatedly. So we consider that one as our mode. The other measurement that requires descriptive statistical tools are the measure of variability or dispersion. Variability or dispersion refers to the extent and manner in which the scores in a distribution differ from one another or from each other, or how much the data is spread out. Here's an analogy. In terms of physical fitness, a person who can do the splits is more agile than the one who cannot. The agile one can spread out more. Data sets that are more dispersed are spread out more. By the way, the other names of dispersion or variability are variation and spread. So when we look at a variable, we can look at the variation. This is the amount of scattering of the values away from the central value. To measure variability or dispersion, you can use the following: range, average deviation, variance, and standard deviation. So range refers to the difference between the highest value and the lowest value in the given distribution. Average deviation is the measure of variation that takes into consideration the deviation of individual scores from the mean. And variance, it is the square of the standard deviation, while standard deviation, it is the square root of the quotient of the total square deviation of the mean and the total number of cases. Sounds difficult, right? But to better understand the measure of variability or dispersion, I have included a link to a video with detailed examples. You can find the link under the description of this video. Now we are done going over the most common descriptive statistical tools such as the frequency distribution, proportion, percentage, measure of central tendencies, mode, median, and mean, variability or dispersion, which are range, average deviation, variance, and standard deviation. Now we proceed to inferential statistics. Inferential statistics is divided into two categories of tests. We have the parametric tests and non-parametric tests. Okay, first let's discuss about the parametric tests. So, parametric tests are tests that require a normal distribution. The level of measurement must either be interval or ratio. What do you mean by normal distribution? The distribution of scores is considered normal when the graph shows a symmetrical shape, or what they call bell curve. In this example, this shows a normal distribution of IQ test result. The graph shows that most of the participants have an average IQ which is between 85 to 115. So according to studies, actually 100 is the average IQ of a normal individual. Okay, so going back to the graph, so in this graph, very few fell into the borderline, which is the borderline here is between 55 to 85, and very few of the participants fell on the genius side, which is above 115. So guys, it is important to note that your data must meet the criteria for you to be able to use a parametric test tool. Okay, So again, the data or the scores that you have must be of normal distribution, and the level of measurement must either be interval or ratio. Now let us learn about the commonly used parametric tests. First is t-test. This test is used to compare two means, the means of two independent samples or two independent groups, or the means of two correlated samples before and after treatment. It can be used for samples composed of less than 30 elements. Here's an example of a t-test. A training program was conducted to improve participants' knowledge on ICT. Data were collected from a selected sample both before and after the ICT training program. So before the ICT training program, they conducted a pre-test. So this is the data for the pre-test. And after the ICT training program, they conducted a post-test. The researchers here wants to test the hypothesis that the training is effective to improve participants' knowledge on ICT at alpha level 0.05. Now we proceed to z-test. Z-test is used to compare two means. The sample mean and the perceived population mean. It can be used when the sample has 30 or more elements. It is the comparison of the means of two independent groups taken from one population with known variance. Here's an example in which z-test can be used. The teacher wants to compare students in her math class, which is the sample, to students in other math classes throughout the district, which is the population. The teacher will administer a standardized test with a given mean and standard deviation. Another type of inferential statistics is F-test, or also known as ANOVA or analysis of variance. It is used when comparing the means of two or more independent groups. One-way ANOVA is used when there is one variable involved, and two-way ANOVA is used when there are two variables involved. An ANOVA test is a way to find out if survey or experiment results are significant. In other words, they help you to figure out if you need to reject the null hypothesis or accept the alternative hypothesis. Basically, you're testing groups to see if there's a difference between them. Examples of when you might want to test different groups. First, a group of psychiatric patients are trying 3 different therapies: counseling, medication, and biofeedback. You want to see if one therapy is better than the other or better than others. Another is a manufacturer has 2 different processes to make light bulbs. They want to know if one process is better than the other. And another example, students from different colleges take the exam or the same exam. You want to see if one college outperforms the other. The most popular statistical tool to measure correlation coefficient is the Pearson R, or Pearson product moment coefficient of correlation. It is an index of relationship between 2 variables, or a measure of how strong a relationship between 2 variables is. Correlation coefficient formulas are used to find how strong a relationship is between data. The formulas return a value between -1 and +1, where 1 indicates a strong positive relationship. So in the first graph here, the graph shows positive correlation since it has positive 0.04 R. And -1 indicates a strong negative relationship. So take a look at the third graph. in which the arrow is downward. This one is expressing negative relationship or negative correlation. And the R of this graph is equals to negative 0.4. If a result is 0, it indicates that there is no relationship at all, just like the one in the middle here. Okay, the line is horizontal, so meaning the data is too scattered and there's no specific direction at all. Correlation coefficient is usually used in linear regression. So what is linear regression? Okay, so simple linear regression analysis, it is used when there is a significant relationship between x and y variables. It is used in predicting the value of y given the value of x. So let's take a look at an example. Oh, before that, let's talk about multiple regression first. Anyway, they have the same purpose, right? Only that multiple regression has more than one independent variable. Okay, so as you can see here, multiple regression analysis is also used in predictions. So the dependent variable can be predicted given several independent variables. So here's an example. The example that I'm going to show you is a simple linear regression. One independent variable, or one assumed independent variable, and one dependent variable. So here we are. This example shows the relationship between ads and revenue rather. So advertisement and revenue. If you notice here, they have the data set. So in the first column they wrote the months, okay, and then the frequency of the radio advertisement, and on the third column it's the revenue is listed, okay, alongside the frequency of the radio advertisement. Okay, if you notice, the revenue is in consonant with the number of radio advertisements. The more radio ads they make, the higher the revenue gets, and that is also reflective on the graph. Okay, there's an upward direction. So the company can now predict that if they advertise this much, they'll get this much revenue. Now let's move on to the second category of inferential statistics, which is the non-parametric test. So if parametric tests requires a normal distribution of scores, non-parametric tests or statistical tools do not require such. And non-parametric tests can be utilized when the data are nominal or ordinal. Okay, so let's start with the first type of non-parametric test. We call it chi-square. Chi-square is a test of difference between the observed and the expected frequencies. And there are two types of chi-square tests. Both use the chi-square statistic and distribution for different purposes. First is chi-square goodness of fit. Okay? So it determines if sample data matches a population. That's for chi-square goodness of fit. And the second type is chi-square test for independence. So they compare, or it compares two variables in a contingency table to see if they are related. The chi-square statistics is commonly used for testing relationships between categorical variables. The null hypothesis for chi-square test is that no relationship exists on the categorical variables in the population. They are independent. An example research question that could be answered using a chi-square chi-square analysis would be: is there a significant relationship between voter intent and political party membership? There are still many types of non-parametric tests, but in this lesson, we only introduce to you the most common one. Okay, so you might be confused. Ma'am, when they use descriptive statistics or inferential statistics? So basically, descriptive statistics only describe a sample. You simply take a group that you are interested in, record data about the group members, and then use summary statistics and graphs to present the group properties. With descriptive statistics, there is no uncertainty because you are describing only the people or items that you actually measure. You are not trying to infer properties about a larger population. Inferential statistics, on the other hand, takes data from the sample and makes inferences about the larger population from which the sample was drawn. A study using descriptive statistics is simpler to perform. However, if you need evidence that an effect or relationship between variables exist in an entire population rather than only your sample, you need to use inferential statistics. In short, you will use inferential statistics to prove or disprove a hypothesis. When in doubt, look at your research design. Is your research design descriptive in nature? Then you may need descriptive statistics. But if your research design is correlation and experimental, you would need to go further and use inferential statistic. Now, I will be including links under the description of this video for your personal or further readings. And tama na. Okay, stop. For your supplemental viewing, especially the statistical formulas of the different statistical tools that I have introduced to you, you may refer to the description of this video. And this concludes our lesson for data gathering procedure and data analysis. Thank you for listening, and you have a good day.